Hi there, Martin, founder of FutureProof here. We're going to be looking at a topic of predicting versus thinking in this video. In other words, looking at whether large language models are truly intelligent. So increasingly, we see articles and video content that argues that the AI revolution is just a scam or overhyped, as it's claimed that all LLMs are doing is to predict the next word rather than having genuine intelligence or creativity. The argument seems to be that LLMs are just more powerful versions of the predictive text functions which have been on smartphones for years. This simplification fails to capture their sophisticated capabilities. This video explores how LLMs demonstrate behaviors that challenge our traditional understanding of intelligence. We'll examine 10 compelling examples that showcase LLMs' abilities beyond simple prediction, from complex storytelling to solving logic puzzles, and we'll consider whether these emergent capabilities show genuine intelligence. Beyond simple prediction. Reducing an LLM's output to simple token prediction is a bit like saying a symphony orchestra is just vibrating strings. While technically accurate about the mechanics, this description completely misses the artistry and complexity involved. The next token prediction focus only addresses the lowest level of computation, ignoring the massive scale, intricate architecture, and extensive training data that enable remarkable emergent behaviors in these systems. Billions of parameters. The models are creating detailed statistical models of language through massive computational resources. Extensive training data. The LLMs are learning from countless words and code examples across diverse domains. Complex architecture. The LLMs are enabling the encoding of abstract concepts, word meanings, and logical patterns. Emergent capabilities. When an LLM predicts the next token, it's not simply identifying the most statistically likely word. It's actually navigating a rich linguistic landscape to produce outputs that are grammatically correct, contextually appropriate, and often remarkably creative or logical. These models encode abstract concepts, semantic relationships, and even stylistic patterns, allowing them to generate content that appears to demonstrate understanding far beyond mere prediction. Creative expression. The LLMs can engage in novel content generation. Logical reasoning. LLMs can engage in problem solving and deduction. Linguistic knowledge. LLMs have a deep understanding of grammar, semantics, and context. Complex story generation. When crafting lengthy narratives, LLMs demonstrate remarkable abilities to maintain narrative coherence across thousands of words. They don't simply complete one sentence at a time. They track character arcs, develop subplots, and maintain consistent storylines throughout extended texts. This capability transcends basic prediction, requiring an implicit understanding of narrative structure and character development. These are key elements when considering whether these systems possess a form of intelligence. Introduction. Here we establish character setting and initial conflict. Rising action. We see developing conflicts and character relationships. Climax. Here we bring conflicts to their peak intensity. Finally, we have resolution, resolving conflicts and concluding character arcs. Doing all of this involves a lot more than predicting the next word or sentence. Poetry generation with constraints. When tasked with creating structured poetry like sonnets, LLMs must simultaneously manage multiple complex constraints. They generate text that adheres to specific meter and rhyme schemes while maintaining thematic and tonal consistency throughout the composition. This requires comprehensive knowledge of poetic conventions and the ability to select expressive language that satisfies numerous simultaneous requirements, far beyond predicting the next most common word in a sequence. Rhythm and meter. We need to have a maintaining of consistent patterns of stressed and unstressed syllables throughout the poem. Rhyme schemes. These follow specific patterns of end rhymes across multiple stanzas. Thematic consistency. The LLM develops a coherent theme whilst working within technical constraints. Functional code from natural language. When prompted to write a Python script for web scraping and data saving, LLMs produce organized functional code that solves a specified problem. This isn't merely predicting the next programming token, it involves decomposing a complex task into logical steps and implementing a coherent solution. The model translates abstract requirements into syntactically correct code, often employing standard libraries and design patterns, demonstrating symbolic reasoning and problem-solving capabilities that bridge conceptual understanding and practical implementation. Understanding requirements. This involves interpreting natural language instructions. Problem decomposition. This involves breaking complex tasks into logical steps. So far, there's been no predicting of the next correct word. Code implementation. This involves translating logic into syntactically correct code. Functional solution. This involves creating working code that meets the requirements. Coherent conversational personas. LLMs can maintain consistent personas like a grumpy pirate or wise elder throughout extended conversations. This requires maintaining contextual memory of previous exchanges and understanding the character role being portrayed, adapting language patterns appropriately as the dialogue evolves. This capability goes beyond generating plausible next sentences. It demonstrates the ability to maintain a complex identity with consistent traits, knowledge, and linguistic patterns over long interactions. Contextual memory. This involves recalling previous exchanges to maintain conversation coherence. Character embodiment. This involves consistently portraying specific personality traits and knowledge. Linguistic adaptation. This involves adjusting vocabulary, tone, and speech patterns to match the persona. Summarization and information synthesis. When presented with multiple lengthy articles on complex scientific topics, LLMs can generate concise, accurate summaries. They extract key points, identify common themes, and integrate details from diverse sources, demonstrating semantic understanding of various texts. The models filter out extraneous information, prioritize details by relevance, and reformulate concepts clearly. This capability indicates a deep grasp of content that extends far beyond simple word association. When they are filtering, they are choosing what should not form part of the next word or token, so this does not really fit with the approach of saying they just predict the next word. Information extraction. This involves identifying key points from multiple sources. Content filtering. This involves removing redundant or irrelevant information, making numerous choices when doing so. Prioritization. This involves ranking information by importance and relevance. Concise reformulation. This involves expressing and therefore understanding complex ideas in clear, condensed language. Cross-domain analogies and metaphors. LLMs demonstrate a remarkable ability to explain complex concepts from one domain using analogies from entirely different fields, such as explaining quantum entanglement through baking. These explanations often create surprising yet apt connections, highlighting the model's capacity to identify abstract similarities between disparate subjects. Surely this can be considered creativity. This represents a hallmark of creative and flexible thinking, connecting ideas in non-obvious ways that facilitate understanding and demonstrate conceptual fluidity across knowledge domains. Complex domain. Here we have abstract concepts that are difficult to grasp directly. Quantum physics, economic systems, or even philosophical ideas. Bridging metaphor. Here we create creative connections that highlight structural similarities between seemingly unrelated domains. Familiar domain. Here we have the everyday experiences and objects that provide intuitive understanding, cooking, sports, or relationships. Solving logic puzzles. When presented with complex logic puzzles, LLMs often arrive at correct solutions through systematic reasoning. For instance, given premises like if all A are B and some C are not B, they can derive valid conclusions by applying logical rules and inference patterns. This capability requires understanding logical structures and employing deductive reasoning. These are processes which are fundamentally different from completing statistically common phrases and are central to discussions of machine intelligence. Understanding premises. This involves comprehending given statements and conditions. Applying logical rules. This involves using inference patterns and logical principles. Drawing valid conclusions. This involves deriving logically sound results from the premises. Composing original music. Although LLMs don't directly produce sound, they can generate musical notation or patterns for various styles, from jazz to classical, and match emotional tones like melancholy or exuberance. This demonstrates an understanding of music theory, harmonic relationships, and rhythmic structures. There's no single right way to develop a melody or piece of music, so surely this is fundamentally different to predicting how to complete a word if someone has typed the first 3 letters into their smartphone. The models effectively translate abstract emotional concepts into concrete musical frameworks, showing a grasp of both technical musical elements and their expressive capabilities. This works with jazz, classical, electronic, or other types of music. LLMs demonstrate an understanding of diverse musical genres and can generate appropriate notation for each, showing comprehension of their distinct structural and emotional characteristics. Explaining concepts to varied audiences. Ask an LLM to explain general relativity to audiences of different ages and expertise, from 5-year-olds to physics experts, and it adapts its vocabulary, detail level, and overall approach for each group. This demonstrates genuine topic comprehension and communicative flexibility. The ability to tailor explanations to different knowledge levels represents sophisticated audience awareness and communication strategy, raising important questions about the nature of understanding in these systems. Child-level explanation. Here we might use simple analogies, concrete examples, and basic vocabulary suitable for young children with limited background knowledge. Teenage-level explanation. Here we have more detailed concepts with some technical terms, balanced with relatable examples and clear explanations of underlying principles. Expert-level explanation. Here we use sophisticated technical vocabulary, mathematical formalism, and references to current research and theoretical implications. Debugging and refactoring code. When presented with buggy or inefficient code, LLMs can identify errors, explain their causes, and suggest corrections or optimizations. They can restructure code for improved readability or performance while maintaining functionality. This requires understanding programming logic, debugging methodologies, and the ability to reason about intended versus actual behavior, demonstrating problem-solving and analytical capabilities that reflect sophisticated computational thinking. Error identification. This involves locating bugs and inefficiencies in existing code through careful analysis of syntax and logic. Root cause analysis. This involves determining why errors occur by understanding the underlying programming principles and execution flow. Solution implementation. This involves providing corrected code that resolves issues while maintaining or improving functionality. Optimization. This involves restructuring code for better performance, readability, and maintainability using best practices. Beyond the caricature, rethinking LLM intelligence. Characterizing LLMs as merely predicting rather than thinking represents a reductive caricature that fails to account for their rich and complex behaviors. These models, through their immense scale and sophisticated training, develop remarkable emergent capabilities including creative generation, logical reasoning, abstract conceptualization, and adaptive communication. As these systems continue to evolve, their capacity for creativity and reasoning will only increase, challenging our fundamental definitions of intelligence itself. The question of whether LLMs are truly intelligent remains central to our understanding of artificial intelligence and its future development. That's it for this video. Hope it got you thinking. Don't forget to check out our other resources on this topic and many others.